So welcome to the second ReLifeCycle demo. My name is Pim, and in this demo I will explain to you how you can integrate the ReLifeCycle plugin with the Wallacei plugin. And Wallacei is a multi-objective optimization plugin. You can download it for free on Food for Rhino, and it's actually a really nice plugin because it allows the results of the optimization to be post-processed. And I use that to actually connect Wallacei to my interface so you can more intuitively compare different materialization variants to enhance your responsible material use. So if you need more information about Wallacei, I really recommend watching their demo videos. They have a lot on YouTube, really elaborate, which is really nice. So I won't go too much into depth about Wallacei in this demo, but mostly about its integration. So for this, I also provide an example script on the ReLifeCycle repository. It's called example file Wallacei integration, and it also consists of a few steps. And the first step is basically the standard ReLifeCycle workflow, which I explained in the previous demo. So in here we make a script for the building here on the left hand side. We extract the building elements. We map materials to those building elements. We combine everything into building, and then we perform a responsible material use assessment, which consists of environmental impact, circularity, and a financial impact assessment. Well, what we can do is we can actually use Wallacei. In here I already set up an example. It has this evolutionary engine, which you can access from the ribbon, and you can place it on here. And this requires a few inputs. The first input is the genes, the things that are variable in the optimization process, and we have to connect sliders to that. And in this case, what I did with ReLifeCycle, I deliberately used sliders to select different materials. And what we can do with those sliders is we can connect them to Wallacei. And how we can do this is basically also in order to connect Wallacei to the ReLifeCycle interface, it is very important to name all of your sliders like this. WLC 1, 2, 3, etc. For two reasons. One reason is if we right click here, we can just click select all sliders, and then our genes are connected automatically. And the names are actually registered by my interface, which I've made with Human UI and Matterhopper. And I use Matterhopper to retrieve the sliders. So you will see that in the end, we can actually switch between different solutions and compare them. So very important, I also say it here, to name all your input parameters as WLC and then a number. The next input is the objectives, and since this is multi-objective optimization, we can choose multiple objectives to optimize on. In this case, I try to minimize the MPG. I just drag a simple data, a number canister to the MPG output of the environmental impact component. For the circularity, I try to maximize the building circularity index, so maximize the circularity potential. We can do that by using the 1/x component, which kind of reverses this, and this allows Wallacei to maximize it, because Wallacei is set up as such that it tries to minimize each objective. So if you reverse it, it will try to maximize it. And finally, we try to minimize the direct costs in here. We can drag and drop those objectives, but we can also, if you name them like this, WLC, click here, select all objectives, and then they get connected automatically. And we can add a phenotype, which is necessary. It's the building geometry in this case, but you can I recommend only adding the phenotype after you've run a simulation, because if you already connected during a simulation, your runtime will increase quite much. However, I've already done a simulation for this case. Again, I recommend watching the Wallacei videos to explore in depth what this is all about. But as you can see here, I've already done a very small simulation. And in order to explore our design space, explore the various solutions that this optimization has made, you have to export some solutions. And in this case, I will just export the Pareto front, which is kind of the non-dominated solutions. We can add them here to our export list. And if we click export, it will take some time to export our solutions. Export finished. And now we have our export in here, the Wallacei genomes and the phenotypes. And as you can see here, to connect it to the interface, we have to connect these outputs to these two canisters. And I will just drag this one here. Let's see, the Wallacei genomes go in there, the phenotypes go in there. All right. Let's see now if we launch the interface. We get our overview results. And if we now go to the Explorer tab and we hit this button, Start Exploring, we get a similar interface pop up on the right hand side of the screen. We have two tabs, a Settings tab and a Compare tab. And in the Settings tab, we can enable the solution selector. What we do in this is now we can adjust the slider, and with the slider we can switch between different solutions that we've just exported from Wallacei. And we can immediately see their results on the left hand side here. So if I switch it, we can see the results change. And by doing this, we can see between different solutions, we can check their materials, see how they do. And for example, here we have a concrete structure. What I can do then is I can name this variant, concrete structure, save it, and I'm going to get it here in my saved variants list. This one has a timber structure. We can change, also save that one. And then let's say we want to compare the two more easily. We can select a variant from the saved variants menu. If we load it, it pops up right here. And then we can set the timber structure as a comparison variant. With the concrete structure, we'll set it as a baseline by loading it. And if we now go to the Compare tab, we can see here at the variant name tab that we have our concrete structure here and our timber structure here. And here we have the results for a concrete structure and here the results for a timber structure. And we can see with deviation percentages in green or in red what's better or what's worse. So the timber structure is much better in this case on environmental impact and circularity. But yeah, as a kind of a trade-off, we have more costs, higher costs in this case. And in this way, we can actually compare different variants and you can choose one that suits your needs, adjust it afterwards where necessary. And if you want to adjust it, you always should disable the solution selector again, and then you can change around your materials again in your script. So that's it basically for this demo. I hope I've informed you well enough, and yeah, have fun exploring.